This video, we're going to prove a theorem and a corollary. The theorem states that if we define p of x to be a standard polynomial, cxx to the k summation, k goes from 0 to m, with integral coefficient c sub k. If a is congruent to b mod n, then p of a is congruent to p of b mod n. Does it work the other way? Then the corollary goes on to say, if a is a solution of p of x congruent to 0 mod n, and b is also congruent to a mod n, then p of b is also 0 as well. If you like seeing mathematical proofs, subscribe to my channel. It's a no-brainer if that's what you like, because no matter what video you click on, it's going to be a mathematical proof. How about we get right into this one? Now, just want to see where it says it. So this is the if part, and that's the then part. So we're given that a is congruent to b mod n. But one of the theorems I proved in another video is that means a to the k is congruent to b to the k mod n for k greater than 0 in integers. Okay. And let's see. That implies that c times a to the k, or let's call it c sub k a to the k, is congruent to c to the k b to the k mod n. All I did was multiply by the coefficient. So now what we have is this. So let's write it clearly. This is for k is equal to 0, 1, 2, all the way up to m. So there are m plus one of these. After all, 1, 2, 3, 4, m plus 0, plus the 0th one. So this tells us that the summation of c sub k, a sub k, as k goes from 0 to, let's see exactly how they defined it, 0 to m, this is going to equal to the summation as k goes from 0 to m of c sub k, b sub k mod n. But this here is nothing more than p of a congruent. And this here is nothing more than p of b. Okay, so it does turn out that if a is congruent to b mod n, then p of a and p of b are also congruent with respect to the same n. Now, the proof of the corollary, is pretty straightforward. It tells you that a is a solution, okay, and a and b are congruent. Well, it doesn't forget for a moment that a and b are solutions. P of a, just based on this, P of a equals P of b. And if P of a is equal to 0 mod n, then so is P of b. Okay. if A is a solution to P of X equals 0 mod N, and A is congruent to B mod N, that implies that P of A is congruent to P of B mod M, which is 0 mod N. Okay, this is saying that P of A is congruent to 0 mod N. And P of A, which is 0 mod N, is equal to this, which is also 0 mod N, as opposed to double 0 mod N. And that's exactly what we wanted to show in the lemma. So if A is a root, then anything that's congruent to A, mod N, everything's mod N. Anything that's congruent to A is also a 0 in mod N. Now, just want to show you that this really is true. Suppose that P of X is, I don't know, 3x squared minus 9x plus 4. And let us do mod 5. Mod 5. Well, we know that 7 and 2 are the same. Okay, so let us look at P of 7. It's 3 times 7 squared minus 9 times 7 plus 4. It's 49 times 3, which is 147, minus 63 plus 4. This difference is 84 plus 4 is 88. And this is congruent to 3 mod 5 because this is 85, clearly a multiple of 5, plus 3 more. Okay, now let's look at P of 2. P of 2 is 3 times x squared minus 9 times x plus 4, where that's x. So this is 3 times 4, which is 12. Minus 2 plus 4, 10, plus 4 is 14. Okay, great. I tried to do more and I messed up. Mod 5. I'm pretty sure that this one's right. So let's see what we did here. 49 times 3 is 147. Okay, I didn't do the bottom one right. You're all telling me, why didn't you multiply by 9? I didn't hear you. It's 3 times x squared minus 9 times x plus 4. Plug that number in, which is 2. This is 3 times 4 minus 18 plus 4. That's 16 minus 18, which is negative 2. And if you add 5, if you add 5 to it, you get 3 mod 5. So P of 7 and P of 2, although they equal different numbers, 88 and negative 2, mod 5 they're equal. Mod 5 they're equal. And remember, I'm making this up, this answer. If P of 8 is 25, Just make believe when you plug in 5 or 8, you get 25. Okay? This is 0 mod 5. P of 8 does not have to be 0 to equal 0 mod 5. It just, this number must be a multiple of 5. 5 must divide that number. Really, 5 must divide the difference, but 25 minus 0 is 25. If this number is 0, then 5 must divide it. So even though P of 8 is 25, it can equal 0 mod 5 or mod some other number, mod 25. Okay, just wanted to point that out. If you like mathematics like this, where we talk theory all the time, I show mathematical proofs, subscribe to my channel. See you guys in the next video. Have a great night. Watch and learn.